Hello, I'm Dror Sapir. This is Lab 7 of Optics 380A. Zuzana is our TA, and this lab is about the Michelson interferometer applications.
Hey, I'm Itay, and in this lab, we're gonna first try to calibrate the interferometer using the Hini laser and count fringes. Then our goal is to measure the wavelength of the AG and the MA sources using the equation. After that, we're gonna find the change in wavelength for the sodium source doublet, and for the end, we're gonna measure the refractive index of air.
The purpose of this lab is to explain what we can do with a Michelson interferometer. These things, as I explained earlier, are the things that we're able to do with it. Our source is a 632.8 nanometer laser, and we have this mirror 1 is right here, M1, and M2 is right here. And we have two paths that the light is going to go through. One of them is from the source into the beam splitter, hitting this mirror, and then going into this card, back through the beam splitter. And then the other one is going from the source into this mirror, hitting the beam. It goes through the beam splitter first, hits the mirror, goes back to the beam splitter, and then goes back to the card. This is where the interference happens. For the first part, we get this calibration factor right here, and we used it to get the HG wavelength, which is 522 nanometers, and the NA wavelength, which is 605 nanometers. They're both pretty close to the real thing, even though they're not exact. From there, we went on to the doublets. We got 5 different samples, and we got the average of the caliper difference, which is 0.766 millimeters. So our delta lambda is 0.478, as opposed to the 0.59 that it should be, which is pretty close. We then moved on to get the refractive index of air. These are the numbers that we got. We got the pressure change 5 times. We averaged it, and then we got the length of the cavity that we were using in air. We multiplied it by 2, and we got this number. We had 20 fringes. And the lambda laser, we changed that to millimeters, so we used the equation given to us, and we got the change in N, and we were able to get delta N over delta P for the equation. We got those right here, and we graphed all the way to 100, which right now, all the way to 100, and this is our graph, N versus P. P is in centimeters mercury.
Over our movement of the table and the interferometer, knowing large enough data set, and the caliper, and miscounting the fringes.